Hello everyone. We have a really interesting problem today. This comes to us from Indian JEE, and they yearly they have a contest to enter the Indian engineering schools, and they are really a treasure trove of good problems to solve. Uh, some of them are not so good, but this one is pretty good, and it's not very hard problem at all, and it tests your ability to actually think how the static equilibrium is established in fluid. All right. Okay, so without ado, let's look at this problem. Okay, so we have initially there was water on both sides, so there's some place there was both sides at level some 0.29 meter. So right now it's at this level. The right side has that level, but initially this actually is let's put the right level more properly above, like that. Okay, and now take a different color. So initially it was somewhere in the middle here, and then it went down to this level. This is actually the main realization in this problem. If you can realize this, that used to be at this level, let's call it H0, and now the bottom is here, and on the other side is over there. The area here is same as area on this side. So what used to be here, I mean, there used to be this fluid here, right? Now it's occupied by oil or kerosene. Now that fluid is moved over here, and because the area is same, this height, it moved up. This height here must be same as the height that it went down over here. So this height is equal to that height. That is a very important thing you should know. So let's call it this little thing that it went down, this height D, and then this height is D. Okay, so at the bottom, let's call it point A. At the bottom, at the same level, let's call it point B. So A and B are at the same level. And since A and B are at same level of water, PA is equal to PB. So that is the fundamental thing you should realize. Once you realize that, everything else is that. This is the second thing to realize. So first thing to realize is this D is equal to this D, and so this thing is on this side is 2D. Okay. From the left side to the right side, the distance is 2D. So that's the first thing, and this is the second thing to realize. And once you realize, the problem is like almost trivial. Let's do the trivial parts. So PA is where's gonna come from? Atmospheric pressure plus this. So you're gonna be P0 plus let's call this rho 1, and this side rho 2 for simple writing, rho 1 G, and you have delta H. Let's call it delta H is 0.1 meter. That this height, I'm going to call it delta H just for simplicity here. And so this side is going to be again P0 atmospheric pressure plus the height 2D plus rho 2G times 2D. So this 2D comes in here. because I'm looking at B. So P0 cancels out, and once you got rid of P0, you can cancel out G, and so D, I can figure out D from this rho 1 delta H over 2 times rho 2. And so this is 800 times 0.1 over 2 times 1000, and it's very easy, 0.04 meter. You can just do this in your head, or you can do this like this and get one of these zeros out of that, and so you get that. Very straightforward, right? So D, we got the D. Then we just our answer want H1 over H2, so that's the decision I have to make on. So let's go what H1 will be. H1 will be that height is, I go to A and add up. So height to A is H0 minus D. This is to A, and then I add delta H to that. And H2 is going to be, H2 is going to go, I go to B and add 2D to that, or I go to, so H0 minus D, so I go to 2B and add 2D to it. So it's basically H0 plus D. And this is H0 minus D plus delta H. So H0 is 0.29 and D is 0.04 plus 0.1. So this is, make sure that you are matching right, 2.5 plus 0.1, and this one matches with that guy, 0.35. And so H0 is 0.29 plus 0.04 is 0.33, and these are meters, so I have H1 over H2 is just 35 over 33, and sure enough we have one of the choices here. Yep, that means you got a B as an answer. It wasn't that bad. You had to kind of, if you go look at this my solution, you really have to realize a couple of things. One of the things that you had to realize was that what goes down here is what goes up there, and the area of cross section is the same, the height will be the same. If the area of cross sections were not the same, that's a complication that can be addressed, then the height will go up proportionally. So it will be volume going down here will be equal to volume going up. So this important to realize. Volume moved on left equals to volume moved on right. And because the area crossing same here, then areas cancel out and you got information in terms of heights. So that's one important thing to realize. And second is that from here onward is it's the same fluid, so the pressure at A is equal to pressure at B. They're the same level, so pressure A equal to pressure at B. Okay. I think that's pretty much it. I'll see you in another video. Bye.